In this lesson, we will write complex numbers in a plus bi form. So a complex number is a number that has two parts, the real part and the imaginary part. So the real part is, of course, the a, and the imaginary part is the bi. So a and b are just real numbers, and I, of course, is the square root of -1. So we're going to practice this in several ways. So first, of course, if I was just looking at -3 would be a real part. So writing it in standard form, I would write -3 or -3 plus 0i. So there was no imaginary part. For my second one, there's no real part, there's just an imaginary part, so I could write that as just -12i or 0 minus 12i. For my last one, notice that this second part is not yet written as an imaginary, but it is the square root of a negative. So I would have the 4 out front. The square root of a negative brings the I out front. 18, again, I would break this into 9 and 2, which would give me 3 and I. So this would be a 3i on the outside and a radical 2 on the inside. So that would be my complex number. Here are a few more. These are, of course, dealing with fractions, which will come into play quite a bit when we're looking at the quadratic formula and finding those complex solutions. So the important thing to remember when you're simplifying with a fraction is first reduce whatever you can in the radical. So looking at this negative radical 24, again, I could break it into 8 and 3, but that doesn't make sense. I would look for 4 and 6 because 4 is, of course, a perfect square. So before I reduced my fraction, I would write this as 8 minus 2i radical 6 all over 6. So I'm actually going to just break it up and write them both over 6 because they want me to write it as a complex number in a plus bi form. So 8 divided by 6 would be 4/3. And then, of course, the 6 and the 2 here would reduce. I cannot reduce this 6 that's inside the radical because it's not a real number. It's, basically an irrational number. So 2 and 6 would reduce to 1 and 3. I'm not even going to write the 1 outside, but I will write the 3, just like that. So this is the complex form of that solution. Same thing's going to happen here. A lot of times you'll see people leave their answer just like this, but if they want you to write it in complex form, a plus bi, just like I did on the last one, I'm just going to write them both separately and then reduce whatever I can. So 6 over 3 obviously reduces to 2, and so that is what my answer would look like. They might be a little bit picky in ALEKS, I can't recall, so it might look more like this. 5/3 I instead of 5i over 3, but it's really the same idea. Over here, we of course would put the I out front or at the end if that's what they asked us to do. So here's one for you to try like that. So press pause, do this question, then press play to check your work. Looking at this one again, I would first reduce this radical -27 by breaking it into a perfect square factor, and of course that -1, we always want to get that on the outside. So I would rewrite this as 6 over 3 minus 3i radical 3 over 3. So the 6 over 3 reduces to 2. The 3 over 3 reduces, and that gives me I radical 3. So that would be my final answer. Typically we'll write that I before the radical. The reason that we do that is if you wrote radical 3i, you wouldn't really be able to tell is that I on the inside or the outside. So we write it with the I first.